Hello, everyone. Welcome to our fourth installment on digital series on sustainability. My name is John Miller, President of Muskoka Steamships and Discovery Center, a registered charitable organization located at Muskoka Wharf in Gravenhurst, Ontario. Our organization adopted sustainability as a core theme over a year ago as another step in our evolution to develop a vibrant cultural hub for the District of Muskoka. We adopted the slogan, "Love Muskoka, Sustain Muskoka," discover ways to make a difference as a branding statement for our sustainability initiative. Our goal is to become the physical and digital presence for community organizations and partners to encourage the will to act against climate change and to assist Muskoka residents and the annual visitors to Muskoka Steamships and Discovery Center discover how they too can make a difference through actions of their own. Our project began in 2017. It's a $7.4 million revitalization to increase the relevance of the Muskoka Discovery Center to the Muskoka region and also, sorry about that. We are a cultural hub and a learning center, and we have 5 new permanent exhibits, 4 of them being located in the addition to our Discovery Center that you see on the screen now. So those exhibits are Muskoka Past, Present, and Future, a non-Indigenous cultural history of Muskoka for the past 200 years, the transformative steam era, the disruptive steam technology that changed the world and Muskoka, Miskuaki, Confluence of Cultures, our feature exhibit in this edition, describes Indigenous presence in Muskoka for over 13,000 years. Love Muskoka, Sustain Muskoka, discover ways to make a difference. That's why we're here tonight. This is our digital series webinar that will lead us to a physical exhibit at the Discovery Center. And finally, Wanda 3, our 106-year-old classic yacht that was built in 1915 for Mrs. Timothy Eaton of the Eaton Department Store fame. We're electrifying this yacht and relaunching her in 2022 to sail once again on the Muskoka Lakes. So those new exhibits will join the most recent permanent exhibits that we added. One of them was Watershed Wonders, everything that you want to know about the Muskoka River watershed. And we opened that exhibit in 2018 with a number of partners. And Water is Life, Indigenous beliefs about water, and a celebration of the water keepers, which we opened in 2020 in the middle of COVID last summer. Those 2 exhibits form our water gallery, which was our first step into environmental sustainability theme. Also on the screen right now, you'll see Muskoka Reflections, which is our magazine that we issue 3 times a year. We have a distribution of over 25,000 people in Muskoka and beyond. And this particular edition features the birch bark canoe in the foreground, which is representative of Miskuaki, our Indigenous exhibit. And of course, the Royal Mail ship Sagwin and Winona 2 in the background, waiting patiently to sail for the summer season. So now please welcome Kevin Boyle, Climate Change Coordinator for the District of Muskoka, and our moderator for the series, to introduce our speakers tonight. Kevin, over to you.
Hi, John. Well, thank you very much, John. The district is proud to partner with the Muskoka Steamship and Discovery Center and our other partner organizations to bring this speaker series to you. Today, we have a great talk around climate change, which of course near and dear to my heart, as I am the Climate Change Initiatives Coordinator for the District of Muskoka. But first, let's just do a little bit of logistics around questions. So in the bottom of your screen, you'll see beside your chat box a question and answer function. Now, when you're asking questions, we ask you to type them in here, but also make sure you do a read of the other questions first, because you have the ability to like or thumbs up other questions, and that'll reduce the amount of duplication we get. And the more likes or thumbs up a question gets, the higher it rises in the order, and then we'll ask those first and make our way down and see what we can cover off. But I am very excited for today's talk. So we have 2 great speakers, Dr. Peter Sale and Dr. Richard Lammers. Dr. Peter Sales is an environmental scientist whose research into ecology of coral reefs spanned a career at the Universities of Sydney, New Hampshire, University of Windsor, and most recently, the United Nations University Institute for Water, Environment, and Health from 2007 to 2014. He remains a distinguished university professor emeritus at the University of Windsor. He was educated at the University of Toronto and the University of Hawaii, and he now lives with his wife Donna in Muskoka, continuing to write and speak on critical environmental issues. He blogs at www.petersalebooks.com, and his 2011 book, Our Dying Planet, tells the story of impacts on the environment from the perspective of an ecologist who has seen the environmental decline with his own eyes. His new book, which I've pre-ordered and very much looking forward to, is called Coral Reefs and will be out later in May 2021. It's been called Peter Sale's Love Song to the Coral Reef and their beautiful but imperiled ecosystems. He brings his expertise in aquatic ecology to the deliberations of the Muskoka Watershed Council. Joining Peter today on the presentation is Dr. Richard Lammers, who's a research assistant professor in Earth Systems Research Center, Institute of Study of Earth, Oceans, and Space at the University of New Hampshire. He focuses on understanding the dynamics of global and regional scale hydrology with an emphasis on human interaction within the hydrologic cycle. His recent efforts have included integrating models across multiple disciplines and exploring methods to qualify resilience and vulnerability of water, land, food, and energy systems. Dr. Richard Lammers is also a member of the Muskoka Watershed Council. And with that, I will turn it over to Dr. Peter Sale to start his presentation. Thanks very much, Peter.
Thanks a lot, Kevin, and welcome everyone on this rather beautifully sunny Muskoka day. I'll try and give you a story that is going to be of interest and cause you to ponder your thinking about climate change. So I'm going to start by sharing the screen, which will take me no time at all. Well, actually, it'll take me more time than I thought. Sorry about that. There we go. Yes. Share. Okay, here we go. So the title of the talk, Climate Change, is this really such a big deal for Muskoka? And Richard and I will do this. I'm going to give you the bread on the outside of the sandwich. Richard's going to give you the meat. And then I'm going to finish up with another slice of fluffy bread to finish it off and make your evening worthwhile. I'm going to start with the change in perspective that has been taking place and go back to the 25th of March when the Supreme Court made a decision concerning the constitutionality of the carbon tax. Now, regardless of what you think about carbon taxes, there's one sentence in their decision that is really worth thinking about, because Supreme Court justices don't use superlatives at random. They refer to climate change as real, caused by us, and a grave threat to the future of humanity. Clearly, Canada's Supreme Court thinks climate change is a big deal. And yet, I've been talking about climate change over the past 20 years. And while I've seen a change in the understanding of the audiences I've spoken to, I still find that the great majority of people do not fully appreciate just how big a deal climate change really is. And I want to explore why that is. Even in Muskoka, it's a bigger deal than most of us give it credit for. Now, to understand this, we need to start with a little bit of history. And I've got an absolutely terrible graph for you to look at. It's terrible because of this rather wonky axis along the bottom, which starts out in the far right in years before the present. Then it switches to thousands of years before the present, and then it goes to millions of years before the present. So to understand this graph, you've got to take it and stretch it way off to the left. But what it is seeking to show in this rather strange way is that, yes, our climate has varied enormously over the life of the planet. There have been times in the past when it was quite a bit warmer than it is now. And there have been times in the past when it was cooler. And there's many different reasons why that has happened. But on the other hand, for the past 11,000 years, sort of starting here somewhere, the climate has been exceptionally calm until very recently. Now, to appreciate that, let's enlarge that part of the graph, and you'll see what I mean. Starting about here, which happens to be just before we began agriculture, climate has been remarkably flat until the last few decades, until recently. We appeared as a species about 200,000 years ago back here. So we've seen some interesting climate way back. But since we had civilization, we've not seen climate that varies. And when you haven't seen climate that varies, you come to discount any scientist who stands up and says, well, climate is now starting to vary. No, maybe not. Human civilization developed during this time a very predictable climate. And it's not predictable anymore. And that's the main message we want to get across. Now, Richard is going to be talking about how much change in climate Muskoka can expect. Before he starts, I'm just going to reinforce one point, which I'm sure he'll make as well. Changes over the next couple of decades are already baked in. The climate is changing. It is going to change further. We've got a pretty good idea of how much it's going to change over the next couple of decades. It's after that where the amount of change really depends on what we do in the next few years. If we go on as we're going, we're heading for a 3 or 4 degree change in temperature by the time we reach the end of the century. If we act to limit it, we can keep that change to 1.5 degrees, which is definitely as good as we can possibly get, but that's where we need to be. And with that, I'm going to turn the process over to Richard for the details.
Thank you, Peter. So in the first half of my slides, I wanted to talk and review just this Planning for Climate Change report that we did, where we tried to understand what was happening in Muskoka and what we think will happen in Muskoka with respect to the climate. Next slide, please. So this graphic from the report, it looks at the historical record of ice on Harp Lake, which is just east of Huntsville. And that top blue line that you see looks at the time of year when Harp Lake freezes. And with that increasing line over time, we're seeing that it freezes about 20 days later in the year. The lower line in pink tells us when the lake ice melts in the year, and there's a very slight decrease. And so what the researchers on that lake have found is that in a 35-year period or so, there's about a 3-week change, a 3-week decrease in the amount of ice that's on the lake. So this is one example of some of the changes that we're starting to see in Muskoka. Next slide. So we wanted to think about the climate, and so here we looked at the historical time periods. We wanted to use long-term averages so that the numbers were fairly stable, because as you know, the weather changes rapidly all the time. So we looked at the period 1971 to 2000. And in this case, there are 2 curves. The blue line on top shows the historical monthly average temperature, and the line underneath it, the lighter blue line, shows the nightly lows. So we've got the highs and the lows. And what we can see is that, yes, it's warmer in the summer. As we know, it's colder in the winter. And on average, it's colder at night than during the day. Next slide. And now we looked at some of these future climate projections, and these are the red lines. And you'll see that the daily highs and lows, as we estimate, as we estimated from these global climate models for the years 2041 to 2070, all of the monthly average temperatures went up. That's for the highs and the lows. And what does that mean? Essentially, that would translate into more hot days in the summer. We would see fewer cold nights. And I don't know about you, but I don't have air conditioning. And so I rely on the cool nights to keep my house cool in the summer. And we're also thinking that we're going to be seeing more winter days that are going to be above freezing. So we have to start asking what are the implications for snowpack and other components of our Muskoka ecosystem. Next slide. We did the same thing for precipitation. In this case, the average precipitation over the historical period is this blue line. And you can see the curves that we're seeing are not as regular. And the precipitation from the future climate models is in red. And what we saw there was that in the period from roughly the end of fall to the end of spring, so July to October, from January to June, and from the end of October to December, what we're seeing from the models is that it looks like there's going to be higher precipitation as we move out into the mid-century. During the period of the, you can back up again. During the summer period and early fall, it looks like the precipitation would be roughly the same as the present day. However, we were sort of speculating, what does this mean for the future? And when you combine this, where the precipitation during the summer is, we think might be the same, but at the same time you have increased temperatures, then you're going to have higher evaporations, which means the summers, we expect them to be drier. So any water on the ground, like soil water or the wetlands, there's a greater chance that they may dry up. Now, I just wanted to add one cautionary note here, is that we're pretty confident from these future climate model runs that temperature is going to go up. That is something that all of the models are showing. The precipitation change is a little bit different. Some models have it going up, other models have it going down. So the error bars around these estimates are much, much higher. So we have to interpret these with some caution. Next slide. So what could this mean? So here's just one example. I think this is from a National Research Council of Canada, I think. This is showing the extent on the left panel, the present day, the range for white spruce. You can see how it's covering all of Eastern Canada, and it extends down into the northern US. By mid-century, that range for white spruce is retreating. It's moving north to a higher latitude, and by the end of the century, you could see the distribution of white spruce be only in areas that are very far north. Peter will also be talking a bit about this when he gets back into the talk. Okay, next slide. So we really have to think about what this is going to mean for vegetation and land cover here in Muskoka. How will this play out with drought? It's going to be, we're not really sure because of the uncertainties in precipitation. What will this mean for wetlands or the wildlife that we're seeing? Are pests and pathogens going to change? How will this impact recreation and tourism, which our economy relies on this so much in all seasons? What about fire? In 2018, we had some pretty serious forest fires in the Parry Sound region. If the summers get drier, are we going to see more fires? Is that going to be a regular thing? What about for stormwater management or energy resilience and a whole host of other aspects of the Muskoka region? So we really need to plan for some of these changes. And in order to do that planning, we need to view the whole system together as a system and as an integrated system. And that's why we need to really focus on this integrated watershed management. And this was discussed 2 weeks ago in this seminar series, and I believe that's already online. So you can go and look at what we had to say then. Next slide. So for the second half of my slides, I wanted to look at, where do these global climate model results come from? And I just wanted to give some background to that so everyone had an idea. These global climate models, or global circulation models, or general circulation models, or GCMs, they're known by a bunch of different names. Effectively, they break the world up into a series of boxes that represent the atmosphere, they represent the ocean, they represent the land surface. And in each one of these boxes, the computer models, the physicists are resolving a series of complex equations that are seeking to find the balance of energy and water, and also the flows of energy and water between all of the boxes. Next slide. And those, while there were a lot of boxes on the globe, when we actually look at the size of the boxes from the global models that we used for that planning for climate change report, we see that some of these boxes or grid cells are actually quite large. The largest one of the 19 models that we used was in this red box, and you can see it extends from the northern end of Toronto all the way up to North Bay. So that's one box with single values in there, which are getting resolved. And the smallest one covered most of Muskoka and extended down to Lake Simcoe. Now, and we have to really ask, are boxes this large, where there's an average value in there, are they really capturing some of the nuances that we need to be aware of? Next slide. So here's an example of one of the processes that's very important here, which is the lake effect, the snow lake effect that we get off of the Great Lakes. We're here in Muskoka, sitting on the lee side of Georgian Bay, which is on the lee side of Lake Huron. And for any of you that pay close attention to weather radar in the winter, you'll know that this graphic is familiar with that. The moisture is just streaming off of the Great Lakes and getting dumped here. When the average grid cell is so large, are these models adequately capturing these sorts of processes? Fortunately, when we did this report, we didn't have much choice as to the data that we could source, but now the global models are getting a finer resolution, and there are also regional climate models that we can start tapping into to get a better view of what's actually happening in this region. Next slide. So another thing that they do with these global models is that they set up a series of scenarios that all of the different modeling groups decide to run, and they make them consistent with each other so that they can compare results between models. And of course, as you can imagine, a lot of the runs are kind of all over the place. Each fine line you see in all of the different colors on this graphic are trajectory, represent a single model run from a single scenario from a single model. And the different scenarios are in the different colors, and they represent scenarios that might be a future where we just keep burning coal, excessive amounts of coal. Some people say there actually isn't enough coal for some of these really extreme scenarios. In other scenarios, they say, well, what if the whole world gets together and gets really aggressive at cutting carbon emissions to the atmosphere? Then you get something like the blue line, where the amounts come back down. These results are from what's known as the Ipcc 5th assessment report. This year, we're going to be seeing the 6th assessment report come out, and they've got a whole new set of scenarios that are called SSPs, the shared socioeconomic pathways. It's a different way of looking at the scenarios, and it'll be very interesting to see how these play out in this new round of climate models. Next slide. So in the third half of the slides, and this is the last half, I promise, I wanted to look at how these changes are in the longer context of time. So Peter already talked about the really multi-million year timescales, And I wanted to focus more on the glacial timescale. So this is a map of the glacial extent from the last glacial maximum. This map, everything in the colors that you see was ice covered 21 to 24,000 years ago. So you can see that almost all of Canada, except for a few small areas, was covered in ice, and that ice extended into the northern US. You can see that Muskoka was well under this large ice sheet. And if we go to the next slide, then we can look at how deep it was. So this is actually from a cartoon, XKCD, which I like because often a lot of the science that's in this cartoon is well researched, because the cartoonist is actually a former NASA scientist from, I believe, JPL, Jet Propulsion Labs, who stopped to continue his cartooning. But what this diagram shows is the thickness of the ice, in this case 21,000 years ago, over these 4 different cities. And that's the blue bar that you see above each city. That's the thickness of the ice, and that's scaled relative to the skylines that you see at the bottom of each. So you can, where Toronto is, you can see the CN Tower. And the ice over Toronto was estimated to be a little over 2 kilometers thick. Over Montreal, it was 3 1/3 kilometers thick, which is a huge amount of water. And some of you may actually ask, where did that water come from? And well, it came from the oceans. So during the last glacial maximum, the 125 meters of sea level was removed. So the oceans were 125 meters lower, and all of that ice was placed over the land. Next slide. So as the ice sheets melted, you had this barren landscape. And now, while these pictures are actually of Greenland from a colleague of mine, Mark Fonstock, that he took at Jakobshavn Fjord, where he does a lot of research, we can also imagine that this is what Muskoka looked like about 11,000 years ago, when the terminus of the ice was retreating past Muskoka. Now, for large parts of Muskoka, it'll be a little bit different because there was actually a large proglacial lake right up against the ice sheet. But there are other areas where it would probably have looked like this. Next slide. So this is my last slide. And so this time series, which is similar to what Peter showed, but this just shows the last 4,000 years. And you can see that the present day, or now, is on the left side, the far left side of this graph. And as we go back in time to 400,000 years, we're going to the right. And there are 3 curves on here. One is global temperature, which is that red line in the middle. Above that is atmospheric carbon dioxide, which is on the top. And then you have sea level, which is the blue line on the bottom. You can see that these curves kind of change hand in hand. When there's a lot of carbon dioxide in the atmosphere, you get higher temperatures and sea level changes. So we're representing a global system. And one thing to notice is that in this 400,000 year time period, we're seeing 4 different glaciations. These glaciations are a little less than 100,000 years long, with brief warm periods in between. And as Peter mentioned earlier, the time period that we've seen now, which is in the last 11,000 years or so, there's been a stabilization of the temperature. But one thing I wanted to say was that if we look at the global mean temperature between now and during the last glacial maximum, we're seeing a global average temperature of roughly 5 to 7 degrees cooler than it is now. That's not a lot of temperature change to create an ice age, right? You don't have to cool very much now. So the question is, what sort of changes are we going to see on our planet or in Muskoka if we warm 3 to 5 degrees? What's our environment going to look at and going to look like? And the changes could be quite rapid. So I wanted to finish there and pass it back to Peter. Thank you.
Thanks, Richard. Yes, and we'll go straight on to the next slide. And I want to dwell on this business of why we have difficulty accepting that climate change is as severe as it is likely to be. And I think there are several reasons that cause us to not appreciate the existential nature of what we're confronting. And the first of these reasons is simply that our experience has all been in this dependable, reliable world. A world with a relatively uniform climate, with relatively uniform temperatures, predictable seasons. We knew when to plant and when to harvest. We could depend on the right time to plant. We knew when the floods would come to irrigate the lowlands and the deltas where we were doing our farming. All of those things are built into our DNA almost by the fact that it's been throughout our civilization. And so when you have a scientist who comes along and says, well, of course, we're looking at models that tell us that the world is going to be really, really different, we tend to say it's not a big deal. We tend to say climate changes in cycles and it'll come back, and 3 to 4 degrees is nothing. You know, I live in Muskoka. 3 to 4 degrees is nothing. Spring comes every year. Get real. You know? But in fact, what we're trying to say is that dependable, reliable world was an unusual time. That it was an unusual time, and that time has ended. There's a second reason why we have trouble accepting the news on climate change, and that has to do with our belief systems. Now, many of us believe in a deity that cares about us, a deity that will take care of us. Nothing really, really bad is going to happen. Sure, there are cyclones and there are earthquakes, but nothing really bad is going to happen. And some of us maybe don't believe in such a deity, but we believe in the balance of nature. Nature is self-regulating and it will take care of itself. And so long as we don't do really bad things, it will go on as it always has. Now, those beliefs may not be correct. And what we're saying is the climate is changing, but those belief systems cause us to resist that. The third point is the climate is changing very fast by geological timescales, but it's still very slow changes in a human context. Now, this picture is not real compared to Richard's pictures from Greenland, but this could have been Muskoka 12,000 years ago, with the edge of the ice as it melted north and the land laid bare. I happen to have some mastodons or something walking around in there. That could have been Muskoka. At the present time, we are warming globally at about 0.18 degrees per decade. This is a tiny amount of extra heat per decade. But that happens to be 10 times faster than we were warming 12,000 years ago. And it's the fastest rate of warming that we've seen on the planet for the last 55 million years. Remember, humans have been around for 200,000 years. So we're seeing something that humans have never experienced before, right now. And what the models tell us is that rate of warming will get even bigger if we continue using fossil fuels. Did you know that the melting of glaciers has, in the last 30 years, moved so much ice down to the ocean that it has shifted the balance of mass on the planet so that the Earth's axis has actually shifted? The Earth is no longer spinning the way it was, it's spinning slightly differently. The North Pole is only about 4 meters away from where it would have been, but it's moved because of the melting of glaciers. And sea level is rising at 3.6 millimeters per year, which is, you know, it's hard to imagine that being important, but that is double the rate that sea level was rising 50 years ago. And in fact, sea level has been almost constant for most of the last 6,000 or 7,000 years. That's how come we could build our cities at the edge of the sea and have seaports and all those things, because the sea level was constant. It's now rising at a pace that is increasing, and that pace is getting to approach the kind of speeds at which it was rising when all those glaciers were melting. The fourth of these reasons for having trouble with the science is that psychologically we're very poorly equipped to deal with slow threats approaching us. We're really good at getting out of the way of saber-toothed cats. That's what we were selected for in our past. That's why we can jump out of the way of a speeding car. But an approaching change in climate that's happening slowly, we don't even see it. And I have to correct this lovely picture because Smilodon wasn't quite as big as that picture predicts. It was still a nasty predator and you wouldn't want to meet one, but they weren't quite that big. So psychologically, we're poorly equipped to deal with the kind of changes that we're being presented with a changing climate. And then finally, there's the fact that a number of people and some corporations have been very busily providing doubt, questioning the science, because these people have interest in sustaining the status quo. You're an oil company, you want to keep drilling for oil. So you tell people, well, maybe the science isn't quite as good as we think it is. Maybe this is all a misunderstanding. Maybe it's all going to be okay. Keep on digging and burning. And if you want to read about the effectiveness of that campaign, the fact that it was a campaign and there's coordination, the fact that it's still going on, this book, Merchants of Doubt, by Oreskes, who's a Harvard historian, excellent book, and leaves you in no doubt at all that there were powerful interests pushing the idea that climate change does not exist. And when you put those ideas together with all these other reasons why we have trouble accepting the idea of a sudden change in the nature of our planet, you understand why people have been resistant to the idea that climate change is a big deal. Now, it's a big deal even in Muskoka. And Richard has shown several of the ramifications of climate change. He showed you white spruce. I'm showing you sugar maple. This map shows the distribution with the core of the distribution, the sort of best climate for sugar maple in green and a marginal climate in orange. And this is the present day, and Natural Resources Canada says that by the end of the century, it could look more like this. There'll still be sugar maple in Muskoka, but they're not likely to be doing very well. And the same is true for all the other trees in our forest. They should all be moving north. And that's difficult for trees to do. And they should be being replaced by trees from the south. And that's going to be difficult too. And so our forests may deteriorate during this process of rapid change as the original trees become less capable of surviving here and the new trees don't come in. And when you change the nature of the forest and the abundance of the forest, you change the water cycle. And when you change the water cycle, you can expect changes to lakes and rivers, not caused by changes in precipitation necessarily, but caused by changes in the forests ability to sequester the water and prevent it getting into the rivers. So big changes to the lakes and rivers that could be caused simply by changes to the forest. And then, of course, there'll be changes due to the changes directly in precipitation. Now, this is the north branch of the Muskoka, just upstream from Wilson Falls. It does become practically dry in dry years right now, but it's very likely that by mid-century, it will become dry in most years. And that has all sorts of implications for our lakes as well. And the changes to growing seasons and to the plants that do well here, because it's not just the trees, it's all the plants, those changes are going to modify the nature of the environment. That's going to have impacts on the animals that depend on those plants. All of these things are going to happen. And incidentally, there are going to be changes to our health, partly because we'll be living in a warmer climate, which might be good for us, I don't know. But also because a whole host of disease-bearing insects are going to discover it's possible to live in Muskoka, whereas previously it wasn't. And so we will have diseases that we have not previously had simply because the climate has become more tropical. All of these things are happening. Now, the good news, of course, is that Muskoka will still be a perfectly livable environment. But the point we're trying to make is that it will be a very different livable environment. There's also going to be costs to our economy, which we've barely touched on. But the Muskoka economy depends to a very great degree on this wonderful environment we have. This environment drives our tourism, it drives our cottaging. This environment drives our economy. And there are going to be costs to our economy if this environment is degraded. So these are things that climate change brings. Furthermore, with this change in climate that is taking place, it's not just a change from here to there, it is a continuous process of change on into the future, so long as we continue burning fossil fuels. And when you have this changing environment, you make achieving sustainability much more difficult. And I found this diagram and thought it was suitably complicated. I didn't know the kind of diagrams that Richard could produce, but this is a suitably complicated diagram of environmental management. And so I just shoved it in there. But the point here is that climate change destroys the predictable world that we've always lived in. And we're going to have to learn how to manage an environment which is changing for reasons other than what we're doing to it in terms of our development activity. It's much more difficult. So what are we going to do about climate change in Muskoka? Well, first of all, we've got to demand and support efforts to reduce greenhouse gas emissions. We have got to avoid a climate change of 3 or 4 degrees by the end of the century, because that will be really way too much to bear in terms of the degree to which it will alter this place we love. Every citizen can play a role in demanding and supporting efforts to reduce greenhouse gas emissions. It's called being politically active and voting for the politicians who have the courage to make the tough decisions. The changes that are required are going to require a major shift in our sources and use of energy. And those shifts are certainly possible, and they're certainly happening, but they're going to have to happen to a very considerable degree. And the idea of zero emissions by 2050 is not just a pipe dream. We need zero emissions by 2050 if we're going to keep climate change under 2 degrees. Now, most economists see the changes that we're going to have to take as certainly costing something, but it's not that big compared to the size of the economy of the world. And mostly, it's very clear that the cost of changing is far, far less than the cost of not acting. The cost of continuing to do the things we've always done and continuing to burn fossil fuels is a cost. It has costs associated with it, which are far, far greater than the cost of changing to other forms of energy. And most economists argue, in fact, that the process of changing to another form of energy is going to stimulate economic activity. There is money to be made in this transition that needs to take place. Now, there's many ways for individuals to participate in this retooling of the economy, which is all part of reducing greenhouse gas emissions. And the biggest one, I think, is the one I mentioned first: demand and support efforts by governments at all levels to reduce greenhouse gas emissions. But there are other things the individual can do as well. And speakers in previous talks in the series have mentioned some of these. I'm not going to mention many of them. I'm just got one here. An electric car is an obvious way to make a dent, reducing your own carbon footprint. And there's lots of other ways of doing it as well. Now, that's the first thing we need to do about climate change: get greenhouse gas emissions under control. The second thing we're going to have to do is we've got to acknowledge the reality of this changing world, recognize the changes that are coming, and we've got to strengthen the resilience of our infrastructure, because some of these changes are inevitable. The flood of 2019, which did significant damage in Huntsville and lots of other places, is going to happen again. And there are going to be floods that make 2019 look relatively small. We're going to have to build in such a way that we can accommodate those floods. We're going to have to recognize that we need to modify our behavior so that we can minimize those floods. We aren't going to be able to get rid of them completely, and we're going to have to learn how to live with them. We can do a much better job of managing water in the landscape than we currently do. And by managing water in the landscape, we can minimize the extent to which climate change pushes us in the direction of big, damaging, costly, life-threatening floods. Secondly, we should be definitely moving to develop integrated watershed management as the way to manage environment and land use planning in Muskoka. This is a complicated way of managing. It is much more complicated than the ways of managing we've always used, but the ways of managing we've always used are inadequate when you have an environment which is changing. And we have got to learn how to do it, and we've got to get it in place so that we are managing for a changeable world, a world different to the world that we've known over the last several thousand years. So to summarize the talk that Richard and I have given, climate change really is a big deal. Even in Muskoka, it's a big deal, and we all need to get on board. Some of the changes are unavoidable. Changes in things like flow of water in our rivers and how extreme those flows will be. Some of those changes are unavoidable. Some of the more extreme of those changes we can probably mitigate. And we can do that certainly if we reduce greenhouse gas emissions. Muskoka is going to change in lots and lots of ways. Muskoka is going to be different to the way it was. Anybody who thinks that Muskoka can be kept the way it is now, or the way I remember it from the 1990s, forget it. That Muskoka is already gone. Muskoka is going to change in many, many ways. The important thing to be optimistic about, though, if we adapt effectively, if we reduce greenhouse gas emissions, if we introduce integrated watershed management, we'll be able to manage those changes so that Muskoka will continue to be the amazing place to live that it currently is. And that's where we should be trying to get to. So thank you. And on behalf of Richard and myself, I say, any questions? And I'm going to stop sharing at this point. There.
Hi, Peter. And we can get Richard, just turn his video on. There he is. Thanks very much, guys, for that talk. Everything from, real data around what's changed in Muskoka, from the 70s to now over time, to Peter, to tackling some of the larger sort of issues. So yeah, I'll go to the questions here. And so we've got the first one here from Terry Reese. Will the water quantity, the ebbs and flows, the seasonal nature of our many relatively stable inland lakes in central Ontario be dramatically impacted? And how can we effectively adapt? And are we currently, or are we able or prepared to? And so I think probably both you guys have an answer for this, so I'll leave it to you to jump in.
You want to go first, Richard?
Yeah, I'll my first thought in hearing that question is that with the temperatures going up in the summers, the water in the rivers and lakes is going to get warmer, and I'm sort of wondering, how is that going to change some of the species that we have in the rivers and lakes, and what will that do to the ecosystems? I don't have a very good sense of what that is. Within the Watershed Council, it'd be good to have someone join us who actually has some of that information and could guide us as to some of those changes. I don't know. Do you have anything to add to that, Peter?
No, just reinforce what you said. I think it's inevitable that our summers are going to be times when lakes are warmer. And that means all kinds of changes to the biology in the lakes that are going to be difficult for us to avoid. It's going to depend a lot on the extent to which the water cycle is altered from what it currently is. And I think we don't really know yet how much alteration there is going to be. But the model suggests that the alterations could be significant, and we're going to have to learn to adapt to change to lakes which are different to the way they are now. And some of our current behavior may have to be altered to keep the lakes in good condition. Rules about what is an acceptable level of use of a lake may become something that has to change because the lakes become different. And we literally don't know that yet. And that's where integrated management comes in, integrated watershed management, because one of the things it does is it's continuously monitoring what's going on and adapting. Instead of having rules which are sort of set in stone, you adapt and change the rules as you learn.
Gotcha. Thanks very much for that. Adapt with a system that's reactive as opposed to set. Good answer there. This one's pretty specific, so I think I just tossed this one up. But how long before the lakes do not freeze sufficiently enough for winter use? Ice fishing, snowmobiling, hiking are used as examples. And I guess this also is an economic question as well as a natural question. If the ice is gone sooner, then it means the summer's open longer. But I'll just turn that over to you.
I can go first on this one as well if you want, Peter. So as Peter said, we don't know. You saw in that one graph that I showed that there are a whole bunch of different outcomes from the climate models. We can't give a year or a date, but I feel confident in saying that as temperatures go up, we will start seeing increases in winter thaws, which is going to, first of all, weaken the ice, and you'll start seeing more accidents midwinter. And then as it gets warmer and warmer, those thaws will get more frequent. So there will be this change over many years. And for some people, they may not notice as much for those that don't use the lake ice. But at some point, with enough warming, you're going to see much reduced winter ice. I would guess that we will always have some freeze of the lakes. The question is, how thick will that be, and will it be thick enough to actually use for recreation?
If I could add to what Richard has said, I agree with everything he said, but I think the question is incorrect because it talks about how long before the lakes, as if we're talking about something in the future. The changes have already begun. We're already seeing lakes freezing less. The construction industry has been impacted in some recent years by the inability to have roads over the ice for long enough to do construction on the islands. These are real changes. And I've been saying to people for some time, if you enjoy ice fishing, do it now, because the ice fishing season is going to get shorter and shorter.
Yeah, I understand. Let's see, moving down the line here. I guess this sort of, will climate change extend the tourist season here, I guess, longer summers, and put more pressures on the lakes and environment?
Yes.
Well,
But it may not put more pressure on our lakes if we modify how we behave as people visiting. It's not necessary that more tourists or a longer season is automatically bad for our lakes. We can manage our use of the lakes so that the longer season doesn't cause greater impact.
And of course, integrated watershed management would provide the data in more real time to be able to understand what that level of use would be and or help in some way.
Sorry, I didn't catch.
Sorry. I said, so an integrated watershed management would help provide data or understanding of the system to be able to react to pressures.
Yes.
Yeah, I think it would allow us to make more reasoned decisions and plans for the future. The other part of it is that there's also increasing population in this region, which is going to put increasing pressure on the environment here. So when you mix the population change and the increased demands with the changes in climate, maybe we could hit some tripping points here and there. How will the increasing temperatures in southern Ontario, will that cause more people to try to come further north in the summers? Is it going to be unbearable in Toronto, for instance? And will that further drive people to to come up here in the hottest weather? So it's just many different factors that are changing simultaneously that make any prediction hard.
Yeah.
And I think sort of in relation to that, I guess with that changing climate, can we expect significant algae blooms in our lakes in the near future? Or I don't know what the person's asking, but basically climate change and algae blooms. Maybe Peter, I'd start with you, or?
The Watershed Council currently has a project underway. It's in a pilot stage at the moment, in which we're looking for a way of monitoring algae in our lakes that could be adopted by lake associations. And we're doing that because we think that climate change is going to probably alter the behavior of algae and make algal blooms more frequent than they currently are. That's one of the unfortunate things about nice warm water. Algae love it. So it's a real possibility.
And Peter, maybe very quickly before I go to Richard, could you give us the most people probably know on the call, but give me the 30-second what the Watershed Council is.
The Watershed Council project.
No, just give me 30 seconds for our audience of just what the Muskoka Watershed Council is. Just the high level. I'm sure most people know, but just to fill them in.
Watershed Council, the Muskoka Watershed Council has been around for 20 years. It is a volunteer organization. It works with the district and with the municipalities. It is an organization which tries to educate and inform, encourage good practices, bring people's attention to issues such as climate change, which was one of our issues recently. It provides advice to our municipalities and the district, as well as to the public. I think it's one of those amazing things that was invented in Muskoka. And it seems to do a job that was otherwise not being done and needed to be done. And of course, I'm biased because I've been involved with it for the last several years.
No, I just wanted to make sure that if we had some people that weren't familiar, that they got a little synopsis. Sorry, Richard, did you have any comments?
If you want to learn more about it, just go to the website, which is muskokawatershed.org, one word. And
we have a link to the Planning for Climate Change document in the chat box, and we'll also put a link to the website as well. Sorry, Richard. Sorry to put that in between there just to make sure everyone's. But algae, any comments on algae?
I have nothing to add on the algae blooms. Any questions that I ever have, I always go to Peter because he's the expert that I use. And just on the Watershed Council, just given that it's a volunteer organization, we're always looking for people to help. So, if anyone is motivated to learn more about the environment, to learn what's going on, to get involved with this integrated watershed management process, now is a really good time.
Awesome. All right, we'll move down from Jane Jones. So I guess this question is using the economic risk to our economy in Muskoka from climate change an effective determinant to help encourage climate action from those that may be in denial?
I can give a few thoughts, or maybe just one thought. Whether or not it's an effective deterrent, that I think that's for a sociologist to answer. I think that all arguments need to be used for all people because different arguments will resonate differently with depending on who you are and what your background is. So it just has to be a multi-pronged approach in using that.
Peter?
I don't think I've got anything to add except to mention that there is a viewpoint that says, the way we've always done things is the way we're going to keep doing things, and it's sort of built into our DNA to some extent. If we keep on that way, we're going to discover all sorts of problems. I think it's much better to be alert to the need to change our behavior, and economic risk can motivate some people who aren't motivated by other things.
And I would probably also add in here that if using an economic argument, then there's also the case to be made that there's huge economic opportunities for people that wish to take advantage of them, whether it's installing solar panels on roofs or just doing whatever to help us get off the carbon. As society switches over to the non-carbon economy, there will be some great opportunities for new businesses. Mm-hmm. And sort of putting it in that positive spin is also very, very useful in making the case.
Yeah, a shift in thinking. Great answers. And so I guess, Richard, maybe I'll start with this next question for you. Always top of mind in Muskoka. What will the increase in precipitation you showed on a graph mean for flooding in Muskoka?
You know, like all the other questions, it's, you know, the answer is really tough. So if it was as simple as more precipitation, you would then think, well, more flooding. However, you mix that with an increased warming in the winter, and if we're getting more thaws of the snowpack throughout the winter, then what you're going to see potentially is a series of smaller floods spread out over time. That might be a good thing in terms of the large you know, the large floods. And we really need we need a better hydrological model that's really looking at the entire system to really get a sense of what those changes in precipitation will bring in terms of the high flows.
Excellent, thank you. Okay, moving down there, let's see. So I guess for international relations, there's a question from Brian here. This is all good, but unless we have China, India, and US on board with reducing their greenhouse gas from coal-fired power plants, our contribution is too small to fix the problem. What is being done to deal with the big polluters? So, tough question.
Well, that's one that's, I think, relatively easy to answer. For someone sitting in Canada, China and the US are both doing better than we are. I won't say anything about India. They've got their other problems, but China and the US currently are both doing more than Canada's doing on greenhouse gases. So we need to step up to the plate to remain part of the community. And we're going to lose if we don't. We're going to lose economically, and we're certainly going to lose in terms of prestige.
Thanks very much, Peter. All right. Could you go into a little bit more detail on changing forests alter the water cycle? And Richard or Peter?
Mm-hmm. Well, I think I mentioned that, and all I'm saying there is that if you have a forest, if you have a good, typical 20th century forest in Muskoka, it had certain attributes so that most of the rain that fell didn't run off into the rivers real quickly. A lot of it got retranspired by the plants straight back to the atmosphere. A lot of it got held in the soil. If you replace that forest with a forest of trees which are not doing a very good job of growing, so they're not using water, maybe they're dying. If your density of trees is reduced because you've got more trees dying of old age than are being produced as new young trees because the conditions are no longer suitable for the species whose seeds are in the ground, then you enter a situation where that forest can no longer do the same job. And that can create changes in the way water moves through the system. Now, we don't know how our forests are going to change. What we see from the evidence and the models of the future, the projections, is that our forests are going to change. And so all we know is that there are these possibilities, and they're possibilities we need to prepare for. It's much better to prepare for the possibility that changing forests will have significant impacts on the water cycle and therefore go looking for those impacts and learn about them than to sit back and wait until those impacts stare us in the face.
Yeah, in terms of just what forests do and their relationship to the river systems, there have been experiments that have been carried out over multi-decadal time periods in New Zealand, in Russia, in Oregon, where they've taken similar sized watersheds that were right next to each other, and they've clear cut the forests from part of these rivers, and they've looked at the hydrology, and the other basin right next to it, they leave it intact as a control. And what they find consistently is that when you clear cut the rivers, you get much flashier flows in the rivers. So there's increased flooding, and you get more water coming out because there's just less trees that are effectively pumps. They're taking the water from the landscape and pumping it into the atmosphere. So just as a real simple thought experiment, the more trees you remove, the more of the water of the rain and snow will end up in the river system.
Got you, less attenuation there. And so we've got another question from Nicole here, and we'll just maybe only take one or two more questions here, guys. We're about time here, but we need to act locally, stop burning wood and propane, change the heat pump for heating and cooling. What else? And maybe I'd add on to that, what are some things that people at home or at the cottage could do to lower the amount of greenhouse gas they produce? Or I guess I maybe extend that, what could people do to build the resilience? Just if you had any quick thoughts on that, I'd maybe go to Peter first, and we'll go to Richard after that. How does that sound?
I think cottagers have opportunities to reduce their carbon footprints at the cottage as well as at their home down in the city. And they should be trying to reduce the carbon footprint whichever way makes most sense. We have a tendency at the present time to try and increase our carbon footprints every time we turn around. And it's a matter of changing attitudes. For example, we were talking about pressure on the lakes from growing population or growing use by a longer season. If everybody used our lakes by having a canoe and going out paddling that canoe or a kayak or a sailboat, as opposed to everybody having the largest wakeboat possible for the body of water, those would have enormously different impacts on the environment directly, and they would also have very different impacts in terms of carbon use. We have a choice.
And Peter, but I would
go for the high carbon, let's be, that approach, or we can say there are other ways to enjoy the natural world.
And Peter, or for Richard, but I think this person wanted to know, what else can we do? So what else, like whether you're a cottager or whether you live here, what else can you do to reduce your carbon footprint? So maybe I'll go to Richard quick, and then we'll go back to you, Peter.
The immediate things are get solar panels on your roof, so that in the cooler seasons, if you're in a cottage, maybe you can not heat with carbon-based fuels, fossil fuels. Can you reduce the number of trips between here and Toronto in the summer? With much improved internet, a lot of folks here have fiber internet. Is it possible to work remotely and then not go back and forth to the city and driving with diesel or gasoline cars? If you do have to drive, can you try and carpool? Get some of the cars off the road, fewer trips, fewer miles driven in total. I also wonder if there's opportunities for planning changes where there's the ability to have more cottages that are combined in larger structures, so they're cheaper to heat. Is that something that needs to be discussed? Some fundamental change to how people live in this region and other regions.
And Peter, did you want to finish your thought there? Because I might have cut you off there.
Okay. I'll just add one thing. Insulation. Many more modern cottages are well insulated and they're effectively 4-season homes. But we have a number of cottages that are 3-season or 3.5 season, and we try and push them into that 4th season. spending a little bit of money on insulation can do an awful lot to cut down the use of carbon if you're using any fuel other than wood for keeping them warm.
And I will say that there is a Save on Energy program that the province offers for that can help out people with socioeconomic challenges around, that will help with upgrades to appliances and stuff. So Save on Energy, we'll put a link in the chat below. And maybe one last question, because we're right at just going over time. So lastly, very quick, gents, I'm going to go to Daryl Moffat. What positive actions, messages could we do? What positive adaptation strategies can you recommend? And we'll put it into like a minute for each, and I'll throw it up in the air for who wants to go first.
I can go first. Just that get involved now in terms of planning. Talk with people. Try to identify solutions. Get the conversation going, and then start doing something about it.
Awesome, thanks, Richard. And Peter, for you?
I'm very similar, really. I think we need to recognize that Muskoka is an incredibly wonderful place to live in, and we have the knowledge already to keep it that way if we want to. And so it's building that desire to make sure we look after it. And we can do this. This is a positive message. We can do this.
And that is great. We can do this. There's a lot of things we can do, and a lot of things we're starting to do better. And gentlemen, I wanted to thank you very much for your talk today. A lot of research, a lot of local research. It's really great to know, to have that resource here. And of course, a link to the Watershed Council Planning Report is in the chat below. That was really great. And so thank you very much, gentlemen. And I'll turn it over to John here. And thanks very much, guys. And I will sign off now. I look forward to next week.
All right, thank you.
Yeah, thanks, Richard and Peter. An amazing presentation. Thank you very much. I'd also like to thank Kevin for being our moderator, and Jordan Waynes and Ann Curley in the background for assisting us with this program. Tonight we had over 90 people on the webinar, so another great turnout for our fourth in our series. So next week we have Larry McDermott joining us for the Indigenous perspective, reconnecting with the natural world. So again, please join us for that if you can. If you'd like to watch this series, or if you'd like to pass it on to someone that hasn't seen it, please refer them to our website, realmuskoka.com. All the webinars are on there under sustainability. So thank you again, everyone, for joining us. Let's all try to get involved, as our presenters have so accurately described in their presentations tonight. Have a wonderful evening and stay safe.